Good day, learners. This is Easy Engineering. This time, we're going to talk about motion along a straight line, acceleration. Did you ever experience riding in a car that moves rapidly and you get pushed back against your seat? But when the car brakes, you get pushed ahead. Or when riding in the bus taking a hard left turn, you seem pushed towards the right. These are some situations that we can say we are accelerating. We mostly experience this whenever we are riding a car, bus, motorbike, and many others. Right now, we are going to learn more about the final mathematical quantity of a motion along a straight line, which is acceleration. Acceleration is a vector quantity that happens whenever there is a change in velocity. Its SI unit is meters per second squared. In mathematical sentence, it is expressed as acceleration A is equal to the change in velocity v over the change in time t. In other words, it is the final velocity minus initial velocity divided by final time minus initial time. Now let us have three different scenarios for you to understand acceleration. First, suppose a runner is running 3 meters per second at a constant velocity. The question is he accelerating? The answer is no, because his velocity is constant. Second, what if the runner is initially at rest and 5 seconds after he is moving at 5 meters per second? The question is he accelerating? The answer is yes, because his velocity is not constant. Initially, he has a velocity equal to 0 meters per second, and 5 seconds after he moves 5 meters per second. Hence, he is accelerating. What if the runner is running at 4 meters per second and then it turns right and continue to run at the same speed? The question is he accelerating? The answer is yes. Bear in mind that velocity is a vector quantity, so as acceleration. That means a change in direction is also a change in velocity. Although the speed of the runner is the same, but changing the direction means changing the velocity, which results to acceleration. Finally, let us try to calculate acceleration. Let us have the second example where the runner is initially at rest and 5 seconds after he is moving at 5 meters per second. What is his acceleration? Let us check your answer. The formula of acceleration is equal to the change in velocity v over the change in time t. The initial velocity v sub I is 0 meters per second. The final velocity v sub f is 5 meters per second. The initial time t sub I is 0 seconds, and the final time t sub f is 5 seconds. Plugging known values to the equation, solving the equation gives us a value of acceleration equal to 1 meters per second squared. I hope you got it right. That is all for now. I hope you learned something today. Once again, this is Easy Engineering.